All right, measures of central tendencies, page 3 and 4. Review properties of central tendencies. A mean is found by using all data values of the data set. Use all of them. Mean of the sample data set will be used in calculations to find other statistics. Because it's a sample, you get statistics from the calculations, right? Mean of a data set is not necessarily one of the data values, right? The mean is not necessarily one of the clipboard numbers that you got. Since it's an average, and we're also, because we can add one decimal over from the average that we get mathematically, it's probably not one of the data values. To find the mean of a frequency distribution, there must not be any open-ended classes like 56 and above. That's not going to work for frequency, the mean. The mean is affected by an extremely high or low values called outliers. The median is used to find the middle value, I guess they want, middle value of the data set. Or you could find center also works, because if it's a odd number, if n is odd, then your sample size is odd, then your middle number is the middle value is the center of the data set. If it's even, though, it's going to be an average of the two middle ones. The median is used to determine if a data value falls in the lower half or the upper half. The median is not very much affected by outliers. The median can be used with open-ended distributions. The mode is used to find the most common, most common case. The mode is the easiest average to find because it requires no calculations. Which data point is repeated the most, right? If there are any. The mode can be used for qualitative data and quantitative data. Variables. Both. The mode is not necessarily unique, I guess is the word looking for, and may not even exist. As in, you might not have a mode if all the data values are different. All right, a measure is resistant when an extremely high or extremely low data value does not change the value. The median and the mode are resistant to outliers. However, extreme values, called outliers, can have a striking effect on the mean, and I would add the mid-range. Okay. All right, so how do you find a weighted mean? It's very common for how your Canvas works, how your grade's figured, and it has to do with the varying weights of the different grades, right? So one of them right here is a math class score. So if your average of all your homework together is 90, and you consider that 10% of your grade, we're going to have to use a little more complicated formula to get your weights in there, okay? Because things count more than other things. There's only one final exam, but it counts apparently 20%. So we need to add these in a way that takes into account their weights. So look at the formula. Your sample mean, that's your X bar, the sum of the value being multiplied by its weight and then added. Okay, orders of operations. And then you're going to divide them by the total weight. Okay, so 90 times 0.1 is 9. 75 times 0.1 is 7.5, and so on. Don't forget how you're converting your percentage to a decimal. You are dividing by 100. That gets it moved over from here. Let me do it this way. If you have 10% and you divide it by 100, it moves the decimal from here and it puts it here. Okay, so 0.1 for that. So if you have 20%, the decimal is here. Dividing by 100 puts it here at 0.2. 75 times 0.2 is going to give me my grade with the weight on it. Okay, and then I'm going to add all of these up and get 76.5. Excuse me. All these up, right, and get 76.5, which is my weighted mean, because we're just dividing by 1 in this case. Okay, but over here, if we got a grade, let's see, so what's that? That's a grade of C in this class. C, by the GPA scale, is only worth 2 points. Okay, but if you're taking a math class that's worth 5 credits, a C is going to be 2 times 5 is 10 for the weighted grade. Okay, and then when you add up all the credits you're taking, you got this person's taking is 13, and then you add that to the weights, add up all the weights, you get a 26. That's your sum of your grade with weights. Okay, so then it's going to be 26 divided by 13 for your X bar, which comes out to a 2.0 GPA. Okay. But we took a lot of time learning how to make classes. So how do we find the average of classes involved? Well, it requires a midpoint. Okay. So remember, midpoints, you add the upper and the lower limits. These are limits together, and then divide by 2. 24.5. 28 plus 33 divided by 2 is 30.5, and so on. 36.5, 42.5, 48.5. And then these are the frequencies. You sum up the frequencies, you get sample size, which is represented by M. So it turns out there's 24. What is this again? This is city miles per gallon for 24 family sedans. So that's right. What does this histogram look like? Do I have any space? Let me try down here. So 16 is the first one. And then 2, 2, 3, and 1. That's what that histogram would look like. What would be considered that shape? Well, it's pulled up by this data over here. So it's certainly skewed right. The mean would definitely be skewed right. It's unimodal, right, because it has one tall peak in it. If you calculate the mean, I'm going to need X bar equals the sum of all the frequencies times the midpoints over the sum of the frequencies. Okay, so I don't have a lot of room to show you how to do that. You can look at the key, but basically it's going to be 24.5 times 16 plus 30.5 times 2, etc., over 24. Okay, so apparently this comes out to 702 over 24, which equals 29.25. So we're going to round that to a 3 for my X bar. All right, so 29 is going to be the average And where would it fall? Let's see, this first one's going to be a limit of 22 and 27, so 29 is going to make it over here, 29.3. This average is pulled, you can see, by the these other classes. Where would the median and mode fall? Well, since it's skewed right, the median is going to be back over here somewhere, and the mode is going to be over here. That's a, yeah, you can't read that, sorry. I don't have a lot of room. That's the median. This is the mean, okay? Because it's a skewed right picture, okay? So would this be the best display for this data set? I'm thinking not. I want to know what's going on here. So I think what I'd have to do is adjust my class limits and make it smaller. Notice that the class width is 6. So maybe you can make it a class width 5 so you can get a little more deep dive into this 16 number. Make it 5, make it 4 for a class width or something. I think that would be better.